Okay, so last hour we talked about the floor systems. So I'm going to do just a quick review, see what you guys come up with on this one. Let's go 32 foot. $32 here, 4 foot, 8 foot, and 32 foot there. And we are going to assume that the beam goes from the center of this wall all the way across, straight across. This is at 16 feet. So I want you to find sills, joists, bridging, and of course floor. So I'm going to give you a couple minutes, see what you come up with, and we'll talk about that in about 4 or 5 minutes. See what we did. Okay, so sills. How many linear feet of sills? What's that? 192 feet. Works for me. Anybody get something other than 192? 192 is the perimeter. For joists, obviously here we need 16 footers, right? Here we need 16 footers. Of course, the run there is 32 feet. So for the joists, it's going to be 12 over 16 times 32 plus 1 or minus 1. We need one here. Do we need one here? Yes. So plus 1. So that is what, 25? So there'll be 25 here and 25 here. Is there any other place we need 16 footers? We'll need them over here, but there are no 16 footers there. There'll be 12s and 8s over there. So we have 50 16 footers. So then right here, this is going to be what length? Well, 16 minus 4 is going to be 12 footers. So that's going to be 12 over 16 times 32 plus 1 or minus 1. Trick question. We don't need one on this end, but we do here. So we're not going to add or subtract. We only need it on one end. If we don't, remember we add one if we need it on both ends. We subtract one if we don't need it on either end. But in this case, we only need it on one end, so we're not going to add or subtract. So it'll just be 12 over 16 times 32, which is 24. Any questions on that?
Yeah. The second part, did you run into trouble if you just put 20 footers across?
Across here?
Yeah.
Let me go over that in just a second. Let me finish this, and then I'll talk about that in just a second. Then, of course, here we're going to need 8 footers, right? And that's going to be the same formula. It's going to be the same number of 8 footers as our 12 footers. So 24 8 footers. Because it's still 32 feet, and you only need them on one end, so it's not going to be plus or minus. And then, of course, we need rims. How many feet of rim joist? Or not rim, just end joist is all this is, but that would be what? 128 feet, right? 32, 32, 32, and 32, correct? Okay. 16 feet here. Well, that's 16 feet this way is the span. The run is the 32 feet. The span is 16. Same here. 16-foot span. This is a 12-foot span. 8-foot span. Bridging. Well, we need bridging here and here, obviously. Do we need it here? Yep, 12 is more than 10. Do we need it here? No. So you're at 32, 32, and 32 makes 96 times 3 288 feet of bridging. Always times 3. Now here we've got 32 by 32 is that area. This is 32 by 20. 32 times 32 is 1,024. Plus 32 times 20 is 640. So this is 1,664 square feet. What do we do with that? Divided by 32, does it come up to 52 sheets? 52 sheets of flooring. Okay. Question came up. Would you get in trouble if you put, instead of doing 12 and 8, if you did 20 footers all the way across, like this. Okay. Well, if you're dealing with floor trusses, what you would do is you would put a post here and leave this beam out, and there are floor trusses that can free span 20 feet. There are TGIs, if you get the 2.5 inch width instead of the 1.5 inch width, they get the 14 3/8 instead of the 11 7/8. Those can also span 20 feet. I believe they have to be 12 inches on center to do it. But if you're using 2x12s, obviously it cannot free span 20 feet. And the problem you run into is if you leave the beam in there and just let it support in the middle, you get it's called a dual span beam situation. Or a dual span is when you have the same structural member spanning 2 spans. And that's what this is. There's a span from here to here, and then from here to here to here. In this situation here, over here, half the load from this joist goes to the beam, half the load from this joist goes to the beam. So that beam supports 1/2 of the total load of the floor. In this case, what happens? I'm just going to draw it out with stick figures here. Here's my beam, right? If you push down right here, what happens is that causes it to lift up on this end. If you do the same thing, if you push down here, it causes it to lift up on this end. Now, this is not a sheeting issue. It's a structural issue. So notice the load here takes weight off of this end. The load here takes weight off of this end. So what happens because of that bending, if this is a continuous beam instead of a split beam like this, here the center takes half the load, here the center takes 5/8 of the load. That does not sound like a lot, but if your beam is engineered really close to what it's allowed, that could push you over the top. If your beam is designed for split joists like this and you do a continuous joist, you can get into trouble. So if you do want to just run a continuous, if you're running TGIs and you just want to run a 20-footer across there instead of having them meet in the middle, you have to make sure that when you have your beam designed, you are telling them that's what you're going to do. But if it calls for 12s and 8s on the floor plan, you cannot substitute without double checking the beam. So that's my little lecture on that for the day. A lot of people don't realize that. A lot of people think, well, if this would hold, having a single beam across there is actually more sturdier. And as far as the joist is concerned, it is, but it overstresses the beam. Your common sense, you look at that, it doesn't make sense unless you really analyze it and get into it. It increases the load on the beam by 25%. One of those little things you wouldn't ever think of. I've seen a lot of people do that. They throw a continuous joist across there. They think that it's a good thing. And it seems like it should be. But like I said, if you're close to the limit of that beam, it is not. So, our next step. Anybody have any questions on what we did? How many of you had the number of floor joists and the number of floor sheets and everything right? How about the bridging?
Couldn't figure out the joist, so
so didn't do the bridging. Drew's totally lost. The recording will be out there for you to watch tonight. Pop some popcorn, sit around the big screen.
What big screen?
Computer screen, whatever.
What computer?
Oh, you'll be
You can see this right
you'll be
here.
staying here. Oh, you can watch on your phone. That works. Hey.
Maybe, I don't even know.
It's on
So
YouTube,
he can't
so-
take notes and watch it. Yeah.
Actually, I can multitask.
Do you actually have a tablet after leaving everything out in the rain?
Wait,
No.
you left your computer out in the rain? No.
Not the computer.
What had his computer in
He
it?
doesn't have a computer.
Oh, okay.
No, I'm talking about like a notebook to write notes in. Well, that's why you do notes on your phone, don't you? You don't actually use paper, do you? Silly.
He multitasks all
Silly paper.
Yeah, I can have
Oh,
multiple
yeah.
windows up. I can have
Okay.
YouTube on one side and notes on
Oh,
the other.
gotcha. You got a fancy phone. Okay, so anyway, our next step. Exterior walls. I know. Let's do a simple one here. 24 feet by 36 feet. You'll notice I'm keeping my dimensions modular for right now. First thing we're going to do is we're going to look at just flat out exterior walls. The number of studs needed. Actually, let's do this. I should do shoes and plates first. Shoes and plates. What are shoes and plates? When you're doing your stud wall, the shoe is the bottom, sometimes called the bottom plate. And of course, on top you have a double plate, right? And you have your studs. Pretend those are evenly spaced or somewhat close to it. So anyway,
So you're saying the shoe is the bottom and the plate's the top?
yeah, the shoe is sometimes called the bottom plate.
Oh, yeah.
Shoe is the technical term for the bottom plate. I always call them the bottom plate and the double top plate.
Yeah, that's what I was.
So anyway, that's just going to be 3 times the length of the shoe is just 3 shoes in place is just 3 times the length of the wall. In this case, just the perimeter of this, which is going to be 120, right? So you need 360 feet of shoes and plates. The only real qualification for shoes and plates is you try to have them in 12 or 16 foot, or if you have to, 8 foot lengths. Anybody know why? Increments of 4 to make them modular, because your studs usually come out on 4 foot spacings. I usually use 12 footers because that's a section of wall that I can tip up and set by myself if I have to, if there's no huge headers in it. A lot of places like to use 16s. The fewer joints in your wall, the better. So anyway, that's your shoes and plates. Number of studs is 12 over your on-center spacing again, times your length. So here, I'm just going to use the perimeter, which is 120. We're going to assume 16-inch on center. So 12 over 16, oops, 12 over 16 times the 120 foot is what? 90 studs. Now, you notice I didn't do a +1 or -1 or anything here because there are adjustments to the studs. Yes, you got to do corners. Yes, so for each corner, since this formula should give you 1 at each corner, we have to add 2. Because when you frame corners, let's say this formula gives you the first one when you're going through your corner, so your studs are looking like this from the corner, right? Going this way, you get your first one here, but at the end of the wall here, I should be careful. Going this way, we don't get our first one here, so the 2 that we're adding the first one to go this way, then we're also adding an extra one here, so we got something to nail sheetrock to from the inside. Does that make sense? That's why they do the doubles on the corners. They do it like this so that you have the sheeting on the outside. The spacing works out for the outside sheeting. They just add that stud, so you're going to cut 5-6 inches off of your sheetrock on the inside. You do one here this way instead?
Yeah, and then one on the outside, and then you got a
Yeah. Yeah, some people will do that. You don't get a lot of insulation when you do that. The thickness of your wall gets very thin. And when you do it, even when you do it this way, you got to make sure you insulate that corner before you put this stud in. Yep. So usually this stud does not go in until after you've sheeted the outside of the building. Spray foam does not work real well in those, by the way. I've seen it pry the sheeting right off the outside of the house. What's that? Well, I know. I've seen people use the spray foam on doors where they went to open the door. You know, they did the spray foam with the door closed. They opened the door and then the frame of the door bowed in almost a full inch after they opened it. They never got that door shut again until they had to whittle all the spray foam back out. Basically remount the door.
Great.
Yeah.
Well, we mounted the one and spray foam.
Yeah, they mounted the door and spray foamed it. But the problem, no, they left the door closed. So it pushed up, and when they opened the door, it sprung in. There was that much force on it.
What's spray foam?
They filled the sucker full.
Yeah.
They're supposed to just do a quick run with it. Yeah, I know. I actually use it's more expensive than great stuff, but it's a zero expanding foam, so it puts like less than half a pound of force up against whatever it hits. You have to have a gun for it. It screws onto the gun, and it's more expensive, but it's nice. Yeah. No, not the big one. No, this is just cans that screw onto a little gun, and then you have to have the special can that you put on it as the cleaner to clean out the gun when you're done, and it's kind of a pain, but it's much nicer because I used to install a lot of vinyl windows, and those, I mean, it takes nothing to bow those suckers in when they start to bind. So anyway, you add 2 for each corner because of that. Other places you would add. Windows and doors. I always call them cripples, but that's politically incorrect. You know, the jack studs. Jack or shoulders, yeah. You add 2 because you're going to have that extra stud on each side. Now people ask, well, what about all the studs you lose for the door? Well, those usually get cut up as part of the headers and the short studs above the headers and stuff like that. So you end up using that all up. You still add 2 for each window and door. Windows, of course, you got to frame underneath and do a bottom sill under the window and stuff. Odd length wall. By odd, I do not mean as in an odd number like 3, 5, or whatever. By odd, I mean not divisible by 4. 4 is the magic number for framing. That's what they call a modular number. Any wall that is not 4 feet long will not work out in our formula. For each odd wall, you add 1. Now this next one is debatable. Interior wall intersection. The packet I'm going to give you says to add 1. The reason they say add 1 for an interior wall intersection. So you've got your 2x6 exterior wall like this. And let's say you got a stud here and a stud here. And your interior wall, 2x4 interior wall, intersects it right here. And of course, there's a stud at the end of that. When you go to sheetrock, by the way, anybody know how far you're allowed to float sheetrock without anchoring it? Yeah. Yeah. 5/8 inch sheetrock can actually span up to 12 inches. So in your ceilings, in fact, they'd recommend you don't anchor it near the wall anymore anyway. The last 12 inches, they request that you leave it free.
Oh, so it can.
What they do now, they recommend you do is actually use an F piece on the wall. It looks like this. It's like an F channel. So you run the end of your sheetrock into that so you don't put any screws within 12 inches of the wall. Then you put your screws anchored up, from here on out you anchor it up. That way if there's any heaving in the ceiling, if it sags due to snow load or anything like that, it'll slide in and out here instead of, yep. But anyway, on a 1/2 inch wall sheathing, it's 6 to 8 inches is what they recommend. So on one side you'd probably be okay, the other side you wouldn't. But what this packet is recommending, and a lot of people do this, is that you use a 2x6 here. So it's going to lap over 1 inch on each side, so you have a place to anchor that sheetrock on each side of that interior wall. The big disadvantage of this is now you've cut this cavity from 5.5 inches down to 4 inches, and you've just lost thickness for insulation. So if you're using spray foam, it doesn't matter. 4 inches is more than enough.
Is that like, just, okay, so your picture is like.
This is looking down from the top. Yeah. This is looking down from the top.
Because wouldn't the top, you just do like 2x6 double top?
Double top, a top plate? Yeah.
Yeah, for a single.
No, this is looking down at it from the top. Okay. So I think I should just let you guys try some of these. So in your packet, again, actually not the way I think I'm going to have you do it. Of course, wall sheathing. Actually, I'm not even going to look at wall sheathing here, am I? We'll talk about wall sheathing later. Wall sheathing, of course, would just be area divided by 32 again. But of course, if you got gable ends, you're going to add a waste factor because you got the angle cuts. But anyway, what I'm going to have you do is I'm going to actually have you use the floor plans on page 238. So in the packet, on page 238, for each of those, I want you to find 1 linear feet of shoes and plates. In other words, plates. And 2, the number of studs. Let me see if there's any in the second part of the packet is better to deal with. There's a great example, by the way, on page 244 of this packet. I'm going through and counting the studs and adding for the interior walls and stuff like that. What's that? I'm just trying to see if there's a better example here quick. I thought there was one that I did before. Where's 15.6?
I feel better now.
Yeah, let's just stick with those. Do the exterior walls. Don't worry about adding anything for interior wall intersections there. Just add for odd length walls and corners. The one on 244, they've already done all the work there, so there's really no sense in doing it. But I would have you look at the example on page 244 there. It's a good one to go through. Okay, I'll give you guys the last 20 minutes here to work. Get you a good start on